Hello, welcome back. A large amount of open data concerns statistics. Yet, open data portals are organized around files. One might ask, isn't there any better way to organize statistical data? And what will happen if we organize open data portals in a better way? In this presentation, I will introduce the data cube as a suitable model to organize open statistical data. The learning objective of this presentation include: first, distinguishing between a file-centric and a data cube-centric open data portal. Second, listing the main characteristics of the data cube model. Third, creating a data cube from existing open data. And finally, listing and using some online analytical processing OLAP operations. Currently, an increasing number of governments and public authorities publish their data openly at open data portals. Specifically, more than 180 open data portals exist around the globe, including the EU Open Data Portal and the Eurostat Data Portal. Most of this data concerns statistics like demographics, economic and social indicators, monitoring the population size, inflation, trade, unemployment, and poverty. Data in these portals mostly resides in files using various formats like XLS, CSV, PDF, etc. The problem with this file-based approach is that data cannot be easily discovered or combined, neither within the same portal nor with other external portals. Thus, it seems that we are building isolated open statistical data silos. Statistical data is not new in the literature, but also practically. Statistical data is often organized as data cubes, where each cell contains a measure described based on a number of dimensions. Although they are called cubes, these structures can have more than 3 dimensions. Data that is characterized by many dimensions is also called multidimensional data. Let's see an example to better understand what a data cube is. The data cube of the example measures the unemployment rate in percentages based on 3 dimensions: time, sex, and geography. So, the unemployment rate of males in Greece at 2008 was 5.1%. Traditionally, data cubes were employed within a single organization that was the only consumer of the data. So the process that was followed was quite straightforward. The first step was to define the structure of the data cube that served a specific purpose. For example, the aim was to model corporate data about the sales of products. Then, relevant databases were developed based on the data cube model and populated with data of the organization. Finally, a number of operations termed online analytical processing, or OLAP in short, were used to exploit the single data cube. The most common OLAP operations include: roll-up, summarize data by climbing up a hierarchy or by dimension reduction. For example, data can be summarized together in the next level of a time hierarchy, such as unemployment data at the quarter level are summarized at the year level. Drill down is the reverse of a roll-up operation. This happens by going down a hierarchy or by dimension introduction. For example, unemployment data at the year level are drilled down to unemployment data at the quarter level. Dice is the operation that produces a new, smaller cube by selecting particular values for multiple dimensions. For example, only data for Italy and Greece, as well as for 2008 and 2011, are shown. Slice is the operation that produces a smaller cube by setting a specific value to one of the dimensions. For example, we slice the cube for year 2014. Pivot operation is also known as rotation. It rotates the cube for visualization purposes. Data cubes and OLAP operations are essential in many areas, including data mining and business intelligence. All this knowledge can also be exploited at the open statistical data. But surprisingly, there is even more. Returning to the lecture's main objective, we will see now how data cubes can be employed within open statistical data portals and which are the benefits of this approach. The relevant process could be as follows. First, existing open statistical data residing in portals is studied to identify cube characteristics like measures and dimensions. Then, data is structured according to the data cube model, for example, for unemployment, poverty, etc., using some common standards. And, more importantly, data cubes are linked to other compatible data cubes in the same or in other portals. Finally, new OLAP operations can be used to exploit all data cubes and not just one. Here, you see a hypothetical example of 3 open statistical data portals that have now changed from file-centric into cube-centric. The new cube-centric approach of the open statistical data portals enables additional OLAP operations. Drill across allows joining 2 cubes with the same dimensions, like geography, time, and sex, but with different measures. In our example, the first cube contains measures on unemployment and the second on poverty. The resulted cube contains 2 measures along the common values of the dimensions. Specifically, the resulted cube has 2 measurements in each cell. For example, for Greece, 2014 males, we have unemployment 23.7% and poverty 47.7%. OLAP operations were not originally perceived to be used at a web scale. Thus, there is a clear need to improve the methods we have for finding compatible data cubes and for joining them. Many different joining cases exist. For example, 2 datasets about unemployment in the same European countries but in different years can be joined. In the example shown, the resulting cube contains data for years 2008, 2011, and 2014 from the first cube, as well as data for year 2015 from the second cube. The adoption of a cubic-centric approach by open statistical data portals brings many benefits. It facilitates the easy discovering and merging of data. It allows data reuse, visualization, and analysis. It also enables the reuse of existing methods and tools, for example, OLAP operations. But there are also many challenges that need to be overcome in order to exploit the full potential of this approach. Organizational challenges include adoption and the use of common standards for producing compatible data cubes that can be easily merged. Another challenge is related to the technological complexity for web-scale deployment, since a large number of data cubes will reside at different data portals. Finally, semantic interoperability challenges still exist that hamper the merging process. Now, in closing this lecture, I will summarize the main highlights. Open statistical data in portals can be organized in data cubes. As a result, existing knowledge and tools, for example, on OLAP operations, can be reused. Moreover, using the data cube model for open statistical data enables integrating data residing in different portals. You might now want to verify and experiment with what you have just learned. Start by visiting a national or local open statistical data portal. Select a dataset and download it, for example, in CSV or XLS format. Try on paper to transform it to a data cube by identifying the measure, the dimensions, and their values. Apply some OLAP operations on the cube. Find compatible datasets that can be used to drill across and join with the initial dataset. What are your key conclusions? Have fun with data cubes. Bye for now.